So welcome everyone. Welcome to the April 2020 edition of Geosaurus Unleashed. If you've been following us over the past few months, you know we've been highlighting the Geospatial Arch Grant recipients. And today we're going to highlight the fifth and last of that cohort group, Stratodyne. And I hope you found the previous conversations productive. I wanted to give a shout out to Quima, Hum, eMerge, and Near. You certainly made us all smarter, especially me, over the past 4 months. Also wanted to give a shout out and thank you to Arch Grants for investing in these wonderful geospatial companies. Arch Grants' commitment continues to support our effort to grow this geospatial ecosystem in the region. With that, we'll transition to today's guest of honor for a discussion. He's Amit Pinnamaneni. Did I get that right, Amit?
It's pretty close, yeah.
Okay, all right. Well, a lot of people have butchered my name, obviously, so don't feel bad. He's the co-founder of Stratodyne. I'm really looking forward to this discussion. BJ and I did a great prep session with the other co-founder, Ed Gee, last evening, and Amit, and as we were preparing for this session, as someone who I feel like I understand the importance and the challenges of persistent monitoring, regardless of what that utility would be. So I'm looking forward to understanding more about their technology. So, Amit, thank you for joining us this afternoon, and I hope all is well with you.
Yeah, it is. Yeah, I'm glad to be here. I'd always love to share more about our technology, and it's awesome to connect with other members in the geospatial community.
All right. Well, we're certainly glad to have you, and I know you guys have been really busy, so it makes it even more appreciative that you guys were able to carve out some time. And I understand Ed will probably be joining us late in the show. He had a little bit of a conflict, but really this has been a monumental year for Stratodyne. So last fall, you and your team were recipients of Arch grants, and part of that first cohort of geospatial companies. And then just a couple of weeks ago, you guys were awarded as one of the companies for the first ever NGA Accelerator. So congratulations. I mean, in a year that's been generally crappy for most people, this is one that you guys will probably cherish professionally.
Yeah, it's really bad time for a lot of other people, but it's honestly a bad situation for the entire world. But the coronavirus brought us, I guess, closer together virtually, and we were able to accomplish quite a lot more just because of this. Like we could spend more time. There's less travel time in between. I'm not meeting with people in person, and this made things a lot easier for us to try and expand and grow bigger. And we got attention from venture capitalists that would never talk to us normally, and they had time to spend with us on Zoom. So this worked out somewhat well for us.
Yeah, well, great. I know it's been a great year for you guys. So I probably need to share with the audience that you and I really, even though we've never met in person, we really didn't get off on the right foot. When BJ we're meeting with Ed and Amit yesterday, I knew Ed went to the University of Missouri, and so I was asking him questions about his potential engagement with Kurt Davis and the Center for Geospatial Intelligence, and then Amit dropped a bombshell on me that he is alum of the University of Michigan. He's actually a Michigan man, and so as most of you know that I went to the Ohio State University, and so anyway, we put that all behind us, and we're looking forward to a great discussion today. So beyond being a Michigan man, what can you share about your background with the audience?
Yeah, well, before I even went to college, I actually took a gap year working for a consulting firm. I actually started interning there in high school, and I worked there as a software engineer or like a general computer consultant. And I worked for a number of different companies. These range from Attempt IT Solutions, Paramount Global. I even worked for the University of Michigan Information Technology Services and Quicken Loans. And then from there, I started attending the University of Michigan, trying to major in computer engineering. and I joined a number of clubs. Some of them it was called MBurst and Project Strato. And I participated in research opportunities related to CubeSats, satellite communications, sensor testing, and so on. So that's where my initial introduction into the geospatial realm and to balloon technology came from.
Okay, very, very interesting. So, hey, so as you were working through your studies and, looking for where your passion was, what really encouraged you to found a company that focused on, high altitude balloon technology and persistent surveillance? And as I understand it, the original concept was for persistent surveillance in agriculture.
Well, it actually goes further back than that, before even the founding of this company. And this kind of relates to the previous question as well. I actually met my CEO, Ed, way back in elementary school, or like fifth grade. And we participated in events such as Science Olympiad and the first Lego League and first robotic competition. Which, on a side note, was actually the first time I actually saw St. Louis. You guys were hosting the first robotics competition, and that was like my first introduction into all the companies, all the geospatial companies in St. Louis. Getting back on track, Ed and I were part of a club in high school called the Northville High School Aerospace Club. And within that club, we participated in a program called the Global Space Balloon Challenge. This challenge was started by and sponsored by MIT, I think Stanford, and the University of Michigan. And it was a program that encouraged students and any participant, if you had your own group or team, you could make your own team, to explore the possibility of high-altitude balloons and create a competition to bring back sensor data or like simple pictures and so on. So that was honestly where I got my first introduction into high-altitude balloons. And as I participated in more research clubs and organizations at the University of Michigan, my skill set improved. And Ed approached me last year, like 2 years ago, discussing the idea of using what we've learned and the sensors and what I've learned over time to use and apply it towards a marketable product. So that's where the company's inception began.
Wow, goes back to the fifth grade, huh?
Yeah, I've
All
been for
right.
a long time.
Yeah. So did you win? I mean,
Well, it wasn't really a competition where there was like, rankings like that. They were like rankings such as best aerial image or most sensor data or stuff like that. I think we won one for some really good images because we were using a high-end DSLR at that time. So we got some image stuff and we got some temperature readings, I think, for us. But,
yeah,
yeah.
nice. All right. Well, let's dig into the technology a little bit on Stratodyne. What is the basic premise and how does it work?
Well, to explain what Stratodyne is, I have to go backwards. So currently, geospatial data is produced by drones, aircraft, and satellites. These current solutions are not as persistent as because drones have a limited time and distance due to battery limitations. Aircraft can't really stay over a specific location for an extended period of time because of fuel concerns. And the price for aircraft is significantly more expensive. You got to hire your own pilot, you got to rent or buy the plane, you got to pay for fuel and so on. And then when we get to satellites, satellites have their own issues where they're expensive to build. You got to spend a lot of money to launch them into space. You got to maintain them for a long period of time. And most of the satellites that have good resolution that matches us are low Earth ones that can't maintain a persistent position over an area and to give you geospatial insights with varying refresh rates. So that's where we come in. We can be seen as a low-cost solution for geospatial data, where we launch a pseudo-satellite or like a stratolite connected to a super pressure balloon that provides high-value, frequent time series data persistently at one location. So it has the ability to process imagery such as vehicle detection, edges or land borders, agriculture insights, all on the edge. And you might be asking, hey, how is this different from a weather balloon? So the difference comes because these are super pressure balloons. These are very different from the traditional weather balloons made out of latex. They don't pop once they get to their maximum altitude. So we are able to position them geostationary by changing their altitude to different wind currents to keep them in the same relative position. So you have wind that's going one way, you drop down to that wind current, and then you can go back up, go to a different one, and that'll generally keep you within a 1.5-mile radius.
Yeah. So do you have different types of balloons, or some tethered, some are just in the stratosphere? I mean, talk about the different.
Yeah. So
Models.
with our introduction into the NGA, or participating in the NGA Accelerator program, we found out that a lot of government programs want to be able to get data from the stratosphere, or be able to have a satellite package that is available. But they all had different use case scenarios. So, for example, the weather team, or the Air Force weather team, they just wanted weather and sensor data. And then a different portion of the government, such as like Transcom, which is the Transportation Command, or people that want to track city and movement data, they wanted something that was tethered over like a much lower area in a much smaller area. So we actually have 3 separate models. One that is untethered, and it's a small package and only does basic temperature and sensor data. And then the second package is the tethered one, and that one has a winch at the end of it and pulls itself down. It's kind of like an aerostat. You were telling me earlier that when you used to serve, you used to see these things, these big aerostats out in the field, and it's kind of similar to that, but it's at a much smaller package size. So instead of a giant blimp, you'd have a very small balloon, and that one would be connected to a small small CubeSat. I'm sorry. And then a third package is obviously our fully untethered one that's at 80,000 feet. That one is the one that's a stratospheric solution.
And so as they collect imagery, how is that? I mean, is there portable ground stations to collect that, or talk about the ground station technology?
So if you're talking about the tethered version, we can actually power it completely off of ground power. If you don't get the option for like an onboard battery system, or a power management system. And that one can transmit directly straight using an actual wire. But the larger balloon in the smaller weather sensing data one uses software-defined radios. The smaller weather sensing one can be detected anywhere on the planet because we use an automatic packet reporting system, and it uses extremely low bound, long frequency ranges, and we can get data from anywhere on the planet. The larger one that sends imagery data would need a base station, probably within a 2-mile radius on the ground. And that one will transmit distances of about 20 miles and have like a data transfer rate of over 500 megabits per second. So you could get live stream video if you wanted
to. Okay. And beyond the balloon technology, are you guys involved in the sensor development, or whether it's multi-spectral or infrared, whatever? I mean, you guys can retrofit your platforms with any kind of sensor or a multitude of sensors.
Yeah. So our current business model prefers to sell data, but you shouldn't really think of our product as you should think of our product more as a persistent aerial platform that can carry any sensor that you would want to the stratosphere and keep it there for an extended period of time. You could turn it into a remote telecom tower and station for emergency communications, emergency responders. You could carry a synthetic aperture radar and sensors on board. It's a very customizable platform, and it can be outfitted for the needs of the user. So if you have a specific sensor that you wanted to put on our platform, if you work with us to embed that sensor, we can do that. So when you're talking about sensor development, we actually work with a corporation called Phase One Industrial. They usually do sensors for aerial monitoring for planes. They build it for planes. And we work with them to develop portions of the way that the sensor processes images, but we don't work on the physical sensor hardware itself, at least yet. Potentially in the future, if we have a really good Series A or B.
Yeah. Okay. Great. Okay. So, well, we talked a little bit about some use cases. Talk a little bit about what was primarily designed for, or what you guys at least had in your head where you're going to make a mark with these balloons, and what are some of the other use cases you're discovering and being able to move into those industry sectors?
Yeah, so that's a great question. So as we've grown, we've started moving into applications away from agriculture and into the enterprise and defense space. We're participating in the new program for the NGA, and so there's tons of new applications for persistent aerial monitoring, defense, and national security. For example, we can deploy our imaging platforms in conflict zones or remote areas that can't be reached by aircraft or satellites for a fraction of the cost. Soldiers can go out there and deploy the balloon with little training, like a few hours. They can deploy this compared to spending tons of money on to deploy an aerostat. It takes multiple like a week or so. So this will keep this can keep our balloons in the sky for months, and it doesn't need like a landing strip like an airplane would, or like a drone would, like a bigger predator. So we're also working on a few partnerships in the sustainability space. Aerial imagery is already being used for a lot of purposes, like monitoring wildfires, tracking emissions, and helping provide data to forecast climate risk. But we're staying above areas. But since we're staying above areas for longer, we can capture data sets with more detail, which helps our users build better models predicting changes on the ground, or to help identify and track objects such as vehicles. So I'm trying to kind of relate this back to the last question. I guess to support all these new use case scenarios, as we were talking about, we got the 3 different versions of our platform with sub-SKUs. So for example, the small one with just weather sensors is a payload of 4 pounds or less. And it consists, if people are curious about the exact sensors, it consists of a wind speed sensor, humidity, temperature, ambient light, and air pressure. And then the emissions sensors on board do volatile organic compounds and carbon dioxide emissions. And then if you're talking about our platform that's tethered, it actually carries the same sensor equipment as our untethered platform. So you get the same resolution data if you're looking for just imagery. And of course, we got the untethered one, which has the full platform. So so I guess that covers basically any other use case scenarios you want to. But as I said, you should really think of our platform as we can carry anything that you want to the stratosphere. Actually, I'm not sure if you've heard of this before, but NASA does a project called Project Bobcat, and Project Bobcat does something similar to us, except instead of staring downwards, NASA goes even higher than us, than 80,000 feet. They go to 120,000 feet, and they actually put satellites to stare upwards into space. So they take telescopes up there using the same high altitude balloon concept. So a lot of the work that we're doing has been de-risked in the technical sense by Google Loon, NASA, or other stratospheric balloon concepts.
Okay. So maybe you need to educate me a little bit. So if I'm in the ag sector and I'm deciding whether to go, have a balloon over my area that I'm monitoring, and I'm trying to decide between that and getting a drone package, a swarm of drones. How do you kind of work through that? Because if, from my uneducated perspective, um, do I really need persistent surveillance or persistent monitoring of these fields? I mean, what advantages do you guys give over just being able to fly a drone over once or twice?
Yeah. So that's a very good question. So we know that our technology is a little overkill for farmers, and we can do a refresh rate far more than they ever needed. But the technology, when we originally developed it, had a much lower refresh rate because we were trying to go for undercutting costs and give them a sense that would be significantly lower than any other options on the market. But the reason why we decided to venture more into these other realms is because we want to be able to develop products that we can sell properly. For example, the agriculture industry might not have as much of a customer base as the defense or security industry. So if we can develop a product that can be used for both sides, we can sell more of it and actually reduce the prices to the amount the farmers would want. And now, why you wouldn't want drones or, for example, like aerial imagery goes back to what I was saying before. The costs would be higher. So let's say that you had like a massive, massive farm. Like if you go to Australia, they have these massive swaths of land filled with like, animals, and they can't cover that with a single drone. They need helicopters that go all the way across. So when we're talking about covering a landmass, it can be way bigger in scope than what a simple drone could ever cover.
Yeah. Okay. Now you sold me. All right. Okay, so let's switch gears a little bit. So let's talk about this ecosystem. So, I mean, you've been an entrepreneur, innovator, in different different parts of the country. So, what are your impressions about what we're trying to build here, and not only the innovation spaces in St. Louis, but our concerted effort to drive geospatial technologies in this region. Do you have an opinion on that, or?
Well, I would say that I'd have two different opinions, one on a technical side and one on a business side. So we're a geospatial company. So it's an obvious advantage for us to be in St. Louis, an opportunity to participate in industry community that's, supported by big players like Esri and the NGA. You can't deny that the St. Louis startup scene has been booming over the years. Like you have new resources like Moonshot Labs, you have T-Rex, you have the new Geospatial Accelerator from the NGA. So it's no brainer for startups in our industry to at least try and have a presence in St. Louis. But we also shouldn't underestimate Arch Grants. They kind of helped us by connecting us to first potential partners and resources within the St. Louis business community. I guess as a first-time founder, and I'm a pretty young dude, so this is my first time venturing into like the corporate space. It's kind of intimidating, when you realize all the things you have to do. You have to, incorporate like all this, all these ideas. You got to do all this bookkeeping. You got to write up agreements for, other businesses and users. But knowing that you have the help, or like, you have the right services is a huge relief. And I'm a technical founder, so I don't really like doing expense reports or payrolls or all this other, like stuff. I like, building and iterating on my product. So having someone else there to help me is awesome. That's something that Arch Grants does. So when you're starting out as a company, $50,000 goes a long way. Like setting up all your companies, registering as Delaware, as a corporation, all the stuff costs money. So I think Arch Grants was like the only organization that gave out tons of non-dilutive grants, so to early stage entrepreneurs. And I think that's extremely helpful to the startup ecosystem. It essentially gives founders the investment that they need to get started. And startups it's an expensive game, because like some of the technology that we're using, like it's in like hundreds of thousands of dollars. These sensors that like I'm trying to use. So, and you're working for free. I'm not getting paid to do this. So in the early months, it's really hard to take that leap if you don't have like, like a wealthy uncle who funds your ventures, or like, something else. So having Arch Grants there is a huge difference, huge difference for early stage startup. Whatever the case, I'm like firm believer that, these upcoming days are the best days for the St. Louis startup scene. And I'm kind of excited to make that happen. So on a technical side, I would say this is also a good question, because it relates heavily to the future direction of our company. And my answer reflects the general trend of how technology is moving in the future. I'll kind of do my best to explain myself, but you're going to have to excuse me if I get a little too technical, but I'm sure I can answer any questions. So as the world moves, towards self-driving cars, you got Tesla, you got everybody's trying to do this, smarter appliances, and you have interconnected devices to the Internet of Things. The concept of edge processing has been getting significantly more attention. And we've learned over the years that you can't do everything on the cloud, and processing everything there is not the most efficient. You got to have at least some power on the edge too. So as you know, Stratodyne's balloon-borne solution was liked by the NGA and selected for the Accelerator program due to our ability to edge compute very efficiently. We don't need to send everything to the cloud or transmit anything, so that makes our platform inherently more secure. At the present moment, our biggest limitation is actually in our processing abilities is something called the ability to use our NPUs. So NPUs are neural processing units, and they basically allow us to run our computer vision and execute machine learning algorithms. Now, the general aerospace field and geospatial field likes to use general purpose computer chips. So, whatever's in your laptop right now, like run-of-the-mill Intel or AMD processors you see in consumer electronics devices. And most oftentimes, these general purpose compute chips are older. Like, for example, the Mars rover, believe it or not, uses a Pentium chip or like from PowerPC from a long time ago. Now, they do this for a number of reasons, but it's mainly because of reliability, and these older chips have less, I guess, problems because they've gone through the full R&D cycle.
Yeah.
But the issue with this is these general purpose chips they can run machine learning algorithms, but they consume way more power. So trying to put them on satellites that use low power and run off of solar cells isn't the best idea. So I think this is where we should innovate as a geospatial community, or like as a lower tech entrepreneur, to develop a domain-specific processor that's designed from the beginning to apply to use case scenarios, like processing satellite images, where you merge RGB and near infrared images to produce multispectral images, or to have more neural processing units on board, which are specifically designed to house algorithms for satellite computer vision and so on. So what I'm talking about isn't new. This domain-specific processing, it's been in the works for a while. So you see Apple with their new M1 chip. They're trying to build their own ecosystem through that. You see Amazon Web Services with their like inferentia chips, and they begin to release domain-specific compute chips. Now, I don't think the industry and the bigger companies in the field would be willing to design or test such a new product or like such a new technology by themselves. So I think this is where it comes down to startup companies such as ourselves, design, test, and prove viability that this is the right way to do things. And as I was saying before, our platform is the perfect case for carrying new cutting edge equipment like this, because deploying our platform is cheaper. There's no risk about it not working on you, because you being out of luck, because you're not out of luck because it's in space. It's in space, or it's like somewhere in like geostationary orbit. It's just like a test bed. Like it'll come back to you. You always get your hardware back. That's why it's in a balloon with a deployable parachute. It's basically the perfect satellite component test bed. So doing a domain-specific chip on our platform would be awesome for the general geospatial world. So I think that's something that hopefully that answers your question. It's it's the technology side and the business.
Yeah, absolutely. I wasn't thinking along those lines, but that was great input. Hey, I know we got a couple questions, but before we get to the questions from the audience, we always like to get to know our guests a little bit better. And so when you're not entering science fairs and hanging out at University of Michigan football games, what do you like to do?
Oh, I love watching U of M continually getting beat by OSU, isn't that? No, I'm joking. So obviously being a Michigan boy, my childhood has been ingrained with cars, and both my parents being Ford engineers, like my passion for cars has only increased. I spend time working on cars. I do some CAD parts for 3D printed car parts. Like for example, like if there's something plastic that breaks in your engine bay or something, sometimes they like to just CAD it for people. They can just build it. And then obviously being a computer engineer, I love screwing around with new technology and electronics. Let's see, I watched Formula One, MMA fights, college basketball. Like for example, the game with U of M versus UCLA where we lost. Like if they didn't have their Juzang as a player, their team would have probably lost. He carried their whole team. U of M would have totally won, of course.
Yeah. Okay, I'll let that one pass. So anyway, there are a number of questions that we have. So from Zachary Phillips, how long can the balloon stay afloat for? What is the swath width for images from a single balloon? And are there tiltable gimbals for off-nadir images?
So our balloons that we've tested have gone up to a year in space. So Google Loon and NASA have tested these balloons up to 2 years, I believe. Yeah. So I think the limit for I think the usual limit is 2 years, but we like to bring it back down earlier because we want to check our own, hardware and to check that the superpressure balloon itself is still, it's still good after the amount of time it's been there. I'm not sure what he means by the swath images, for images from a single balloon. I think that'll, like, the swath width depends if you're talking about what's the amount of area that is currently being covered. That'll depend on how high the balloon is or where you station it at. So if you get our tethered balloon, you'll only be able to cover like the specific amount that you can cover within 400 meters. So, or if you have it lower than 400 meters, it'd be even less. And then we have a gimbal, but I'm not sure what he means by off nadir images, because the only two images that we have a multispectral color infrared based sensor, and that is based on a 3-band. Sorry, it's a 3-band color. So the RGB and then a near infrared, and that combines to get us our multispectral images. At least that's what we've been working with on currently.
Yeah. So the question is, instead of pointing straight down, can you point off the nadir?
Oh, okay. We can. I think we have an option to do 20 degrees. That's the only option we have right now. We can definitely modify our platform to carry something even more that can do more oblique images. But at the current moment, the sensors that we're working with can only do it by 20 degrees. So,
okay.
Yeah, I hopefully that answers the question.
Yeah. I think that was exactly what Zachary was looking for. George has a question. Are there, so what makes you different? Why aren't any of your competitors approaching this problem in a similar way?
Well, I would say that our competitors, I feel like, well, I think this should be honestly a question that should be addressed to my CEO. But if we're talking about in terms of our competitors' technology, they're not looking to launch as such cutting edge technology as we are. Like, as I was saying, our platform allows us to test the most cutting edge technology that we can and get the most out of that. So we can do extremely large edge processing that they cannot do because they're using something older. So I'm not sure why they're not approaching it in the way that I'm thinking of, because you can actually test a bunch of new hardware and bring it back, and you don't lose your platform. So that would be a question I'd ask my own competitors. But yeah, I wouldn't know. And yes, we do have balloons in the sky. We have 2 pilot programs, tethered programs that are over. I believe they're over. One of them is over the University of Missouri, some test farm that they have, and then another one is, I believe it's like a family-run farm, and both of those have been a good source of data for us, in between testing and such. Our first pilot program for the full untethered one, I believe, is going to be later this year, around July.
Yeah, cool. Where are you planning on launching that?
In Missouri. So we've tested like fully untethered balloons before, but we haven't tested it with the full all the sensors on board. So we weren't carrying. I think we were only carrying an RGB image at that time. So we're just trying to iterate our platform up there. So at the current moment, these pilot tests are done. Well, honestly, they were done just verbally. So our CFO, Bryce, he used to go to farmers and talk to their neighbors and be like, "Hey, this is Stratodyne. We want to be able to put this on your farm. You can spread the word about us." And then these, paid tests. We get revenue or like income through them, and they, I guess I should iterate that. I mean, I guess I should say that they also signed up through our website. So our website had like a contact form, and you can sign up through there. And we had a lot of people interested through there. Can you give an example of cost per time in the air for practical application? What sort of practical application? It'll depend, because as I said, we have 3 different applications. One's that is just sensors for weather data, one that has imagery array aboard but is tethered, and then one that's completely untethered with a multispectral imagery solution. So it would really depend on what sensor you're using on board, because you need to take the cost of everything else. Multispectral imagery tethered is great. Okay, so I believe, yeah, I wouldn't know off the top of my head. I'd have to ask Ed on that, because he takes into account like the launching costs and the maintenance costs and everything. And in my terms, I only know about the technical costs and how much it's costing us to build the platform itself. So I would have to get back to you on that. I'm not totally sure about that at all. So
Yeah,
I'm sorry about
and
that.
Ed's supposed to jump in here if he's out of his meeting, but anyway, if not, we'll get back to you. I do have a question, another question. So so you've obviously taken some sample imagery, or at least test imagery. Is that, or will that become available for people who want to develop against it, or is there any way to get sample? You know, we're a data hungry environment, right? So anytime we can get sample data to develop algorithms or whatever.
So we, for our front end, we actually just partnered with Esri. So we're planning on using ArcGIS Enterprise, and ArcGIS has the ArcGIS Marketplace, which allows you to put any imagery on there. So you guys probably could get our imagery through ArcGIS Marketplace if you're using that. I'm sure that we'll release some imagery that, as long as it's not like has customers you know, imagery in it. If it's just imagery that we're taking randomly, we'll be able to put that on, but we can't put all of our imagery on there. It'll only be like specific portion. People can use that imagery to test with and you know, train computer vision algorithms and such.
Yeah, absolutely, cool. George had another question about ROI on the equipment. I assume he's talking about the balloon minus the whatever, I guess,
Yeah, so
sensors.
once we have a pretty good like, well, if he talks about return on investment equipment, it really depends on like if we keep our balloon or not. There's some times when we replace the balloon and we relaunch the equipment itself, and all of the equipment gets reused, like all of it, everything below the balloon. So that includes the radar reflector, the parachute, the steerable parachute controller, and then the entire chassis itself. All of those get reused. The cost of those, I can't give you out a cost of those, because that would give out a little bit too much information. So yeah, so I can't give you the cost of the entire platform. I can give you a ballpark estimate at like of our most expensive one that we currently want with all the sensors on board would be in the $100,000 range if you wanted to use that. So if we just want to buy the platform itself with all the sensors on board straight from us, but we're not in that business right now. We're usually just doing data. So I wouldn't know the exact return on investment on that. That's something that has to go towards my CEO as well.
Yeah. Okay. All right. We've got a few more minutes. Any other questions for Amit? Or any questions that you we can follow up later on? Would be fine. There we go. You mentioned working when, and do you have any examples of its use yet in the defense industry?
So we don't have examples of its use yet, because we only just got into the NGA program this last month or so, and we've been working with them to develop these solutions. If you're talking about like a direct example, I wouldn't, but we have weather data that from our weather-based one that is probably going to be used for the defense industry. But I would say that we would have more examples and more information about that once we run our full, pilot program for the NGA later this summer. So that would be a question to ask us then.
And then one more question from George. Is there any pictures, any images of the balloons?
Yes, there are, but that is in our slide deck, and I cannot share that until you talk to us to invest in us or elsewise. So,
okay. All right. All right, that's great. So if there's no other questions, Amit, thanks again for taking the time. I know you guys are super busy. For people want to get a hold of you after this, what's the best way to reach you or Ed?
So keep in mind that we have two accelerators, actually almost three that we're participating right now. So we're extremely spread thin. So if you do email us, it might take us a little while to get through it. Or if you have questions about our technology and everything, we will eventually get to answer those. But you can always reach us at info@stratodyne.space. I'm always open to chatting at Amit@stratodyne.space, and then Ed can be reached if you have the questions on ROI and equipment, or all the questions I couldn't answer. You can email him at ed@stratodyne.space. I can put those in the chat if you want me to.
Yeah, that'd be great.
Okay.
And all right, there was one question that snuck in there about how you maintain the position of the balloons.
Oh yeah, so I did explain that earlier, but we have the ability for geostationary positioning by changing the altitude for different wind currents that allow our vehicle to stay in a relative position. So I didn't explain that well. If you have wind currents going in different ways and you want it to stay in that relative area, you simply just drop down to the wind current in the direction that you want it to go to, and then you go back up towards the other wind current, and you stay in a relative circle area for like about I think it's like a 1.5 mile radius. So you can do it through there, I guess. Hopefully that explains this question well.
Yeah, that's good. Hey, all right, thanks again, Amit, for taking out the time. I know you guys are extremely busy, and we wish you guys the best of luck with the Accelerator, and looking forward to seeing you in St. Louis probably next month, hopefully next month. And so a couple public service announcements before we leave. So next, since we're finished with this Arch Grant cohorts, we're gonna have a discussion next month with Kevin Pomfrey from William. He's a corporate partner at Williams Mullen Law Firm to talk about geospatial policy and geoethics. And the next Geo Innovation speaker series for May will be Will Cadell, the founder and CEO of Spark Geo. He'll be matched up with our moderator, Tony Sardella, the founder of Evolve 24. And they'll be talking about geospatial analytics and how it can give you the competitive advantage for different industry sectors. So tune into those. Those are great forums and great speakers and moderators. So with that, we'll end this. And Amit, thank you again, and thank Ed for our discussions. And we look forward to seeing a lot more of you in the future.
Yeah.
All right. Okay.